method forward interpolation, backward interpolation is only for equally spaced. Equally spaced means when the domain difference is same. The value of the x, their difference is always same. Am I right? Could you remember the last view problem? The interval is same, but okay, I'm just showing you the PDF. It will be more clear. Could you remember when do you see my screen?
No, sir.
You don't see?
No,
Okay, I'm not
sir.
sharing. Just wait. I'm not sharing here. Now,
No, sir.
No, sir.
I already share my screen. What happened? I already share my screen. Now, can you see?
No.
No, sir.
What happened? Hello? Everyone has same problem, but in my screen it's
Sir.
show that I'm sharing my screen.
Sir, you're sharing, but we can see your screen, sir.
Yes, sir.
Again, cancel sharing. What happened? Any reason? The network connection is okay, but
Sir, I think you join and rejoin. Maybe
So
this
Now
now
we
it's
can
problem is
see,
okay.
sir.
solved.
So now we can see, sir.
it's okay now.
Yes, sir, we can see now.
Okay, okay, okay,
Yes, sir,
okay.
I
In
can.
X below, when you have to like this 1, 3, 5, 7. Every times, what is the difference? Every time, what is the difference?
Two, sir.
True, sir.
2. Okay. So here is we call it it's
Yes,
equally
sir.
space. We call it is equally space. Okay. All of you understand what I said? We call it equally space. This this tabular method is equally space. That times we can use the forward and backward. That times we can use the forward and backward interpolation. Okay. All of you understand? Hear me? Hello.
Yes, sir.
Yes, sir.
So that times what do we use? Forward and backward interpolation method. When? Please response. Hello, please response. If you are not hearing, you should be response.
Yes, sir, hearing.
Yes, yes. When the space is equal, that times we use the forward and then backward interpolation method. So we already discussed this, okay? Now
Yes, sir.
today I'm going to discuss the method unequally spaced. Unequally spaced. That means sometimes the value of x like this 1, 5, 6, okay, 8, 9. It's equally space here. Is it
No, sir.
equally space? So if these types of unequally space we have, so what types of method we use here? Okay. So this method today I will going to discuss because we already know that when we have the equally space, we know two methods to solve the these types of problem. Okay, using the interpolation. And now today I'm going to discuss the another method which will help you to solve the these types of problem when it is unequally space. Is it clear? Oh, now going to slide. So all of you understand what types of things, topics today I'm going to discuss?
Yes, sir.
Okay. Just right. I'm opening. The interpolation. Chapter 3 interpolation. Okay. This first two method we will discuss here. The last method will be backward. Russell formula. Stone formula. Practical interpolation. The formula here, but I'm not. Yes. So all of you see here. Hello. So the interpolation with unevenly spaced point. Unevenly, that means unequally, okay, which is not, the space is not uneven. That means which is means the space is not equally spaced, okay. We'll discuss in the present section the next four such forms: Lagrange interpolation and Hermite interpolation, Newton's general interpolation. Okay. So I'm deciding going to discuss the Lagrange interpolation, the first one. So if you know the only one method, so I think it's enough to solve this types of problem. All of you understand what I said? If you know the only one method, no need to run the all method here, okay? Newton's general interpolation formula, which use there, we call the divided difference, okay? This method also important, but I'm not going to discuss. I think Lagrange interpolation is enough to, if you know that this method, you can easily do it. Okay, here is the description, okay? I'm not going to discuss the description. I go to the formula. Is it okay? If I discuss the, all of you hear me? If I discuss the method here, it will not be, we have no enough times to do this whole things here. Okay, so here, where the formula, where are main formula here? Yes. This is our main formula here, okay? Ln, this means Lagrange interpolation. Ln equal I equal n, I equal 0 to n. And here is a phi of n plus 1x, x minus xi, phi prime, n plus 1, xi, and yi. Someone said that what is the phi? Okay, so don't be serious. Okay, I'll one by one discuss everything. First, we write down the formula here. Okay, all of you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so from the book it will be difficult to write down the formula. Just first follow my lecture. Okay, you write down this formula from here. I think it will be easy for you. Lx. I'm not writing here lnx. Okay, if you want to write lnx, no problem. lnx equal is a summation. First one is what? First one is what I say.
Sir, summation.
Summation. Yes, I equal. This the formula is important. Okay, if you know the formula, yeah, I think everything is okay. I equal to any equal to 1 to n. Okay, and after that, okay, the lower part I'm writing here first. Okay, the upper part is difficult. So lower part I'm writing x minus xi, x minus xi. Okay, and after that, here is a yi. Okay, here is a yi. So here will be phi. What is the phi? What is this? What is this? Someone asked me that what is this? Just wait, I'm going to discuss. Phi n plus 1, phi n plus 1, sorry, phi n plus 1 xi, maybe x, phi n plus 1 x, and here will be 5 prime. Okay, every 5 prime means differentiation. Okay, prime means what? Prime means differentiation. Okay, sorry,
Okay, sir.
xi, xi. Just see, we have two difference here. Here is phi n plus 1 only x. And here what we have here? Phi prime n plus 1 xi. All you understand what I said? What we have? Two different things we have here. N plus 1 x. One thing is like this. Problem in writing. X. Another is what? Phi prime. Another what? Phi prime n plus 1 what? Xi. All of you understand what I said? Here is a xi, here is a x. Two different things here. So what is the phi n plus 1? Phi n plus 1 means the multiplication of multiplication of difference between the domain. Okay, so like this: x minus x naught, x minus x1, dot x minus xn. Okay, so like this, if I write down here phi. Okay, if someone so that problem, so you can write this way: pi of x equal what? X minus what? X naught. Okay, x minus what? X1. X minus, sorry, x minus what? Because in the table you have fixed x. Okay, so that times it will be automatically easy for the problem. Okay, so what will here? X minus xn. X minus xn. Understand?
Yes, sir.
All of you hear
Yes,
me?
sir.
And 5 prime xi
Yes,
what?
sir.
5 prime xi what? 5 prime xi what? 5 prime n plus 1 and xi what? Okay, here is xi. Keep in mind that here is xi. Okay, so here always keep in mind xi minus x naught. Okay, what will happen here?
X minus X naught.
Yes, xi minus x naught. Xi minus x naught. Okay, I'm writing here. Is just remember this way. xi minus, and just describe details, more details, just wait. I'm writing fast. Xi minus x1, xi minus x2. Okay, continue up to xi minus xn. Is it?
xn.
Is it? Okay. Someone said, sir, this is a prime, that means differentiation. So where we have done the differentiation? Am I right? This is a prime here. Is it? Here is a
Yes,
prime
sir.
here. Do you see? So where is the differentiation here? We already done the differentiation here. You don't see, because just listen. What and 5 prime, okay, 5 prime and plus 1 x means what? D by dx. Am I right? D by dx, am I right?
Yes, sir.
D by dx, phi of x. Is it? So that means you are going to differentiate this whole part. Am I right?
Yes,
You are
sir.
going to differentiate this whole part. So in these things we have xi. In these things we have xi. So what will happen here? So x, when you differentiate x, what you get? When you differentiate x, what you get?
Sir, 1.
1, 1. So that means when you put the xi, so x will be xi. Am I right? X will be
Yes, sir.
xi. So here, when you
Yes, sir.
differentiate, just see here, x equal xi. Do you see here? X equal xi. So when you differentiate, so this one part, any in the rest of the uh, all value, one will be vanish automatically. Automatically one will vanish. Why one will vanish? Just keep in mind that x equal xi. First time just think x equal 1. So x1 minus x naught. x1 minus x1. x1 minus x1 equal what?
Sir,
x1
0.
minus 0. So that times a whole things will be 0. Am I right?
Yes, sir.
Whole thing should be 0 here, but here is not 0. Why not 0? Why not 0? Because before going to 0, it's automatically differentiate. Because you cannot put the value x1 minus x1. Understand what I said? Like this. You say just xi equal x1. Okay, so you cannot put the value of x1 minus x1. You have to write x minus x1. So that times when you differentiate d by dx, so this will be what? 1. This will be what? 1. And rest of the remaining part is here. What I said, all of you understand? I think someone did not understand here. You have to realize critically. Just see that here. Here is a long value x minus x naught, x minus x1, x2 minus x3, x minus x3, x2, x2 minus x minus x. This way is continue. Am I right?
Yes, sir.
Okay. So when you are going to differentiate, here is a xi. Okay. So all term is xi minus x naught, xi minus x1, xi minus x2 dot and differentiate this. Am I right? You put the xi value after differentiation, not before. So when you're going to differentiate, so here is x, all are x. Am I right? So which part you differentiate here? Because only an conditional value is x minus x1. If this x1, so you cannot put the value x1 here because it will be 0. So this x will be differentiating by this term. Okay. So if this critical, so don't think about that. Just remember this value. Okay. So what is our formula now here? If I write down the full formula, just see. If I write down the full formula here, what is the formula here? Okay. The formula will be Lx equal summation of, don't put the value of I first, okay? 0 n. In the upper part, what we have? Writing, I am facing problem. X minus x1, x minus x2, x minus x3, sorry, x minus, sorry, uh, from the first again, Lx equal summation x minus x naught, okay, x minus x1, x minus x2, dot dot, okay, I'm going to do dot dot, x minus xn. The upper part, any problem? The upper part, okay, and put here x minus xi. What do we have? X minus xi, and here is I equal 0 to, and all of you hear me?
Yes,
All
sir.
of you hear me? What I said? Okay. So what is here? Xi minus,
Sir, xy minus
what is
x
here?
naught.
Yes, xi minus x naught. Okay. Here, just think xi minus x1. Another term is, keep in mind that xi minus xi minus 1, xi minus xi minus 1, xi minus xi plus 1. That x, there is no xi minus xi. All of you understand? Do you see here? There is no xi minus xi. Keep in mind, okay? Okay, if we solve up a little more clear here. So here will be what? Xi minus x1. And here is xi minus x2. Dot dot, okay? I'm not writing more, dot dot. Okay. So if you want to go to write down more step by step, if you write down the details of this summation, so what is happening? Just I'm writing, okay? This is the important things. Now I'm writing the main formula. One part, I'm writing 3 part, okay? 3 part. Any problem? Any problem? This is the important things here.
No,
So
sir.
when I equals 0, when I equals 0, when I equals 0, upper part is same. There is no difference in the upper part, okay? Any problem? There is no difference in the upper part. X minus x1, okay? There is no difference in the upper part, okay? Dot dot. Okay? Every times there is no difference in the upper part, okay? First you write down the upper part. All of you hear me what I am saying?
Yes, sir.
So there is
Yes,
no
sir.
difference in the upper part. Always write down the upper part as like this, okay? Because it will in the problem it will be fixed. How many x value you have? How many x value you have? It will be fixed. So that times you can easily solve. Understand? And here also upper part is same. Always upper part will be always same. Okay. In the Lagrange, upper part will be always change. Keep in mind. Okay. X minus x2. Okay. Dot dot. Okay. If we continue it, no problem. I'm writing the 4 here. So what will be the lower part? Just see. X minus what? X minus what? I equal what? First times what do you consider? I equal what? First time what do you consider? I equal what?
0, sir.
I equal 0. So x minus?
X naught.
Yes. Keep in mind. I equal 0. Keep in mind. Okay. For this, I equal 0. For this, I equal 0. And next, xi. Xi equal what? Do you write x naught minus x naught? Do you write x naught minus x naught?
No, sir.
All
No,
of you
sir.
hear me?
It will be
No, because we will not write x naught minus x naught, because in these things here they write down xi minus xi1 minus 1, xi minus xi plus 1. There is no xi minus xi. Understand? So what will happen here? You start from here. This will be automatically vanish. You start from here. Xi minus x naught minus what? X naught minus what? X1. X naught minus what?
X2.
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 X naught minus what?
X3.
X3 plus dot dot. Okay? Now understand?
Yes, sir.
In the second part, what will happen? Tell me. X minus what?
Sir, X minus
I
X
equal
1.
1. X minus x1. Okay. And after that?
X1 minus X naught.
Yes. X1 minus x naught. Next?
X1 minus X1. Sorry, it will
No.
be banished, sir.
It will not vanish. It is not be here. Okay? Because in the x1, that's why we have the differentiation. This x1 minus x1 is vanished before the differentiation. Okay? So what will happen? X1 minus
X2.
x2. X1 minus what?
X3.
X3 dot dot. Okay? Understand? So here x minus what? X2.
X2.
So x2 minus x
X naught.
naught. X2 minus x1. Okay. X2 minus
X3.
x3. Okay. So this way you continue. Okay. So how you so this is your main formula here. Okay. This is your main formula. So all of you understand? If you don't know the formula, it will be difficult. When you solve the problem, this formula use. Someone says, "Sir, dot dot what I do?" Because in the problem, x will be fixed. Maybe 3 value, maybe 4 value, maybe 5 value here. Okay. So that times you will just put here x minus 3, x minus 5 this way. Understand?
Yes, sir.
Yes, sir.
And this is your main formula. And from here, you can write down this. Okay. So how many 5 minutes left only. Okay, I'll not discuss any problem today. Next class, I'm going to discuss this math. One problem here. So all of you understand here the problem? All of you understand?
Yes,
Is it
sir.
difficult?
No, sir.
I think it's not. I think it's not difficult here. Okay.
Yes, sir.
Yes, sir.
So here is the problem. Just see here. Find the Lagrange interpolation of degree of 2f of 0 y equal to define the following table. Determine the value of 2.7. 2.7 where? Here. Maybe. So this is not equally space. Am I right? So we can
Yes,
easily
sir.
find down here. We can easily apply the Lagrange interpolation method. Okay. Next day, tomorrow we'll discuss again this problem. But you should study the formula before you start the problem. Please, I request you study the formula. Okay.
Okay, sir.
So the rest of them only 34 students here. Okay. Thank you. You can leave now.
Assalamu alaikum, sir.
Assalamualaikum, sir.
Assalamualaikum, sir.
Assalamualaikum, sir.
Assalamualaikum.